Hello, Math Knights. This is Ron Martiella, and welcome to Things That Rock. Recently, I was able to test this lesson out in third grade, and so I want to share it with you. You're going to see, after I'm done talking here, a flipped video that you could introduce to your students on how to find fractions of a group or fractions of a number. So you can have your students use the Jamboard activity that's over there on side B on our professional learning choice board. Or if you're viewing this on YouTube, you can look down in the description for a forced copy of that Jamboard. So I wish you well as your students rock out with Jamboard and finding the fraction of a number. Take care. Hello, Math Knights. This is Mr. Martiello, and today we're going to be extending our understanding of fractions as a number, because fractions can be a part of a shape, it can be part of a line, and a fraction can also be part of another number. Let's find out how we do that. Right now I'm working on a Jamboard, and you're going to be working on a Jamboard too, much like this. And I have a fraction written down, and it's part of a statement. It says 1/3 of 6. 1/3 of 6. I wonder how I find 1/3 of 6. Well, let's start with what I do know. What I do know is how to make thirds out of a shape. We're going to use the square in the middle here. I'm going to move this over. And we're going to divide this shape into thirds. So take this square, and I'm going to divide it into thirds. I'm going to make them vertical. So now that I have this shape broken into thirds, how do I use it to find the fraction of a number? I'm going to use these handy dandy chips over here. So I'm going to erase that line I just made. And I'm going to take, how many chips do I need? I need 6 chips. So I'm going to put them into the thirds. So kind of like I did with equal groups, I'm going to take 1 chip there. I'm going to put another chip there, 2 chips, 3 chips, 4 chips, 5 chips, 6 chips. Well, that's awesome. So then what's 1/3 of 6? Well, if I use my thinking about this shape and the fraction that I cut it into, this here is 1/3, this is 1/3, and this is 1/3. And if I need to know what 1/3 of 6 is, 1/3 of 6 is 2. 1/3 of 6 is 2. Let's see if this works again, because sometimes things work in math and then I try them again and they don't work, but maybe this will work. Let's see if we have some, it's called repeated reasoning. Does this work again if I try the same thing? So I have a shape here again, and I have another statement. This statement says 1/4 of 8. 1/4 of 8. I wonder how many pieces I need to make in this shape. I wonder how I need to partition it, kind of like we did back in second grade when we partitioned a square. I can make fourths if I cut the square this way. I want to make 4 groups, 4 pieces, 4 equal pieces, 1/4, and this would be 1/4 here. This would be 1/4. This would be 1/4. This would be 1/4, and this would be 1/4. 1/4, 2/4, 3/4, 4/4. Okay, I have my fourths. But then how do I find 1/4 of 8? Let's try that fair share thing, where I take one of those pieces and I move them into each one of the fourths. So I'll count. I'll put 1 here, 2 here, 3, 4, 5, 6, 7, 8. I have 8 altogether. I broke them up into fourths. Notice how each group has the same amount. It's the same size, just like a fractional shape. But here we're looking at numbers. So what is 1/4 of 8? What is 1/4 of 8? 2 is 1/4 of 8. Wow, I wonder if that works again. It happened twice now for me. I wonder if I can make this work again. Let's find out. 1/2 of 10. Oh boy. 1/2 of 10. I want you to think about this. You can even pause the video if you'd like. What does 1/2 of 10 look like? Remember what I did first? I cut the shape into a half. So now I have 2 halves, right? And now I need to find 1/2 of 10. So let's do our fair share and make sure we have equal groups. So, oops, undo that. I'm going to go to my thing. See, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm running out of room. 9, 10. If this is 1/2 and this is 1/2, what is 1/2 of 10? What is 1/2 of 10? 1/2 of 10 is 5. And you know what? I'm almost thinking, like, doesn't this sound a lot like 10 divided by 2 equals 5? Isn't that almost like the same thing? I'm making a connection here to division and multiplication, because 2 times 5 equals 10. Oh my word, making the connections. Fractions and multiplication and division are very closely related. Let's try a different one. Oh, wait a minute, Mr. Martiello. This one's a little different. You're asking me for 2/3 of 9. I changed the numerator. Let's find out how to get this done. I'm going to follow the same procedure. I'm going to try it the same way because my brain is thinking this way and it's going well so far. All right, so I'm going to break this into thirds. So there are 3 equal parts because I have a denominator of 3 parts. How many parts do I need? I need 2 of those parts. So when I go to find 2/3, I'm talking about these 2 pieces together. Because this is 1/3, this is 2/3, and this is 3/3. So I need these 2 together. Let's do our fair share. We're trying to find out 2/3 of 9. So I have to make sure they're distributed equally. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, one of the things that I could possibly make a mistake on here is saying, well, the 2/3 of 9 is 3. Because in the last couple of problems, I only took the one group here. But it's not saying that. I need to have 2/3 of 9. So I need to take the circles that are in the 2/3, the 2 equal parts, and I have to put these together. So what is 2/3 of 9? 2/3 of 9 is 6. When you start working with numerators other than 1, then we have to start thinking, well, okay, I did my fair share. Now, how many of those groups of 3 do I need? I need 2 of those groups of 3. And That's how I got my answer. There you have it, Math Knights. How do we find the fraction of a number? We can utilize a shape, partition it into the fraction, and then use fair share to divide the number of pieces into each of those groups to find the fraction of a number. Good luck to you as you continue your journey with exploring fractions as a number. Take care.